However, this apex can also activate the tyrosine of the protein, similarly providing like a bio-ID type map. So utilizing peroxidase and tyrosine exposed protein, when you provide hydrogen peroxide, phenoxy radical is generated, and this phenoxy radical can be used to couple tyrosine of the protein, making protein tagged with R group. R can be biotin, azide, alkyne, or anything else you want, maybe fluorophore or anything. So using this technique, people have identified several proteins which were not previously identified, and there are chemistry groups as well as chemical biology groups focusing on development of several phenolic moieties such as phenol, aniline, naphthalene, and several others, and not only containing biotin but also alkyne, and several substitution on the aromatic ring were also explored. However, not only that, this apex HRP system can also be used to sense the hydrogen peroxide, since it contains catalytic cycle which has the heme oxidation and reduction. So each cycle of this catalytic reaction requires 2 hydrogen peroxide molecules, by which if you have endogenous level of hydrogen peroxide production, using apex you can use biotin phenol probe which can label the protein, and depending on the labeling you can know if there was peroxide present at that moment or not. So people have identified that there is a matrix which is mitochondrial protein tagged with apex 2, and when desthiobiotin phenol was provided, when menadione which is also vitamin K in general terms, when 30 micromolar was injected to cells, it started producing a lot of hydrogen peroxide, and most of the time doctors just prescribe menadione to patients. However, it is not sensible to eat it in a higher concentration. So this is one of the applications which can be solved by peroxidases. Not only that, since this phenol moiety can be tagged to the protein in presence of apex, we decided why not use this phenol with the copper chelating moiety to direct our probe to the protein where we want it. So in vitro we tested that this probe can modify the BSA, and also in the cell when we expressed our apex on the live cell surface, we thought copper bound ligand can be directed to the cell surface only. The beauty of this system is, even though there are cells all over the place, however, cells which are expressing apex can only do the click reaction. So by doing this, we can control the genetically modified cells and ask them to carry out the click reaction. So this is one of the controllable methods using the enzymes. Sometimes when we are working with the human tissue or animal models, we have a problem of not being able to genetically modify the organism. For that, we developed a HAFP Franken-Body system conjugated with apex 2. This apex 2 can target any of the ligand receptor system which can be replaceable and interchangeable. By providing apex on the cell surface, you can create again a microenvironment with a copper-rich system and carry out the copper click reaction when both of these antibody type system is available. We tested this on HA tag as a receptor and anti-HA alpha apex 2 as a ligand, which is shown in this picture as well, where you see only signal when there is everything present with the antibody bound target. All the previous techniques, they were not able to identify metabolome because metabolites do not have any phenol or lysines. So we decided why not use our copper click based system to make artificial alkyne azide copper click. And as you can see on the top lane, when propyl choline, BTTA, copper and peroxide all were provided, the lipids were lit up with the sodium ascorbate and azidocoumarine fluorescence. While when any of these things were missing, we did not see any signal. So it can be a tool to study metabolome as well. We decided to explore cell surface system. So this was a bit complex system where we were expressing